Alright, 5.4, solving radical equations. It's kind of like what we've done in the past, where you have to isolate the variable, or in this case we have to isolate the square root, or the radical. So first thing we have to do is divide by 2. So we get the square root of x plus 3 equals 5. And then we have to do the inverse operation. So the opposite of the square root of something is to square. So we're going to square both sides, and that will undo the square root, and we'll be left with x plus 3 equals 25. Subtract 3, so x equals 22. Now there's going to be solutions that don't turn out to be actual solutions. They're called extraneous solutions. Extraneous solution is when you do all the algebra correctly, but if you plug it back into the equation, it does not produce a true statement. So we're going to check to see if 22 is a solution. 22 plus 3 is 25. The square root of 25 is 5 times 2 does give us 10. So it is a solution. But it's important to check to see if it is a solution or not. Especially, in this section 5.4, solving radical equations. Another example. So negative 4 times the cube root of 2x minus 5. We need to get rid of the negative 4, so divide by negative 4. So cube root of 2x minus 5 equals negative 3. Undo a cube root, you need to cube. So we're going to cube both sides. We get 2x minus 5 equals negative 3 cubed is negative 3 times negative 3 times negative 3, which is negative 27. And just a couple more steps here. So x is negative 11. Let's see if negative 11 works. 2 times negative 11 is negative 22. Minus 5 is negative 27. Cube root of negative 27 is negative 3. Negative 3 times negative 4 is 12. So it works. So negative 11 is our answer. I've got 2 more examples. Let's say I have the square root of 4x minus 1 equals the square root of x minus 6. Alright, so normally we have to isolate the square root. They are there's more than one square root, and they're already isolated, so we can just undo the square roots by squaring both sides. So you're left with that 4x minus 1 equals x minus 6. So x is negative 5/3. Okay. Let's check negative 5/3. 4 times negative 5/3 is negative 20/3. Minus 1 is negative 23/3. Okay, so we get a negative number inside the square root, so that's not even a possibility because it's not a part of the domain of the problem. Same is true on this side. If I plug negative 5/3 in there, I'm going to get a negative number. And we're in the real number system, so you can't take the square root of a negative number. So this right here is extraneous. It's an extraneous solution, meaning that one actually doesn't exist. So there is no solution that does exist. If I graphed y equals this and y equals this, they will never intersect each other. So sometimes in this section you could get 2 solutions. You could get both of them will work out. You could get 2 solutions where one of them is extraneous, one of them isn't. So this extraneous one doesn't turn out to be a solution. It's possible that both of them would be extraneous. So you have to check your answers to see if they work and see if they're extraneous or not. Alright, last example. It's a little bit different. It's the so fractional exponents. 5x to the 2/3 equals 4. We'll divide by 5. So x to the 2/3 equals 4/5. We need to undo something to the 2/3 power because we're looking for x, not x to the 2/3. So if I take this to the 3/2 power, the reciprocal of that, and multiply those, you get 6 over 601. So x to the first is just x. That's what we're looking for. We're looking for x. So x equals 4/5 to the 3/2 power. Okay, so since we're taking, if it was like x squared equals 4, we would be taking it to the 1/2 power, which is the square root. So x would be plus or minus 2 here. It's plus or minus because it's an even root on the bottom. Here we're taking it to the 3/2 power, so since it's an even number on the bottom, we do have to include plus or minus, since it's an even number on the bottom.